Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are working on quadratic relations. We're looking now at word problems that stem from quadratic relations, and this is question number 2 from a worksheet. Here's the question. So again, my suggestion is if you haven't done this question, please press pause, try it on your own, like legit try it with paper, pen, calculator, all that fun stuff, and then continue the video to compare your answer with mine. So here we are. The question says, a pebble is dropped from a bridge into a river. Its height in meters above the water, t seconds after it is released, is modeled by this equation. So there's an equation that compares height and time for a falling pebble. And then we're going to answer these 3 questions. But before we even look at those questions, let's look carefully at the equation given, as we always do. So again, it's height versus time. It's in a weird order. So whoever wrote this question wrote it, I would say wrong, because I like things to be in standard form. So let's first of all rearrange the equation so that it's in standard form. So the t squared term has to go first, and of course the coefficient stays the same. So it's negative 4.9 t squared. There doesn't appear to be a t term, so if you want, go ahead and save its place like this, but we don't need to see it. And then the final part then is that we have positive 82 as the c term. So there's the equation written properly. So what do we know? Well, again, we have a negative parabola, which makes sense for a projectile on Earth. And we have a starting position of 82. So let's think about what's going to happen with this equation. Again, we're comparing height and time. So height and time. Where does the pebble start? Well, we know it starts on the bridge, and we know it starts at time equals 0. So when time is 0, the pebble is 82 meters above the ground. So 82 meters above the ground. And we're told that the pebble's dropped. So there's no upward motion of the pebble. It's purely just dropped. So that means that my parabola would only show up as half a parabola because it doesn't go, for example, up and then down. We're told that it's simply dropped. So because it's dropped, we get this half parabola, and then we know that somewhere over here is this impossible, but mathematically considered other half of the parabola. So this is what happens in the question. So let's go ahead and see what we're supposed to do mathematically. How high is the bridge? Explain. Well, we just talked about that. We know that if, oops, let me not use yellow so we can see it a little more clearly, that when t equals 0, the pebble has the same height as the bridge. So if you let t equal 0, we get an answer of height equals 82, and therefore the bridge height is 82 meters. Good. So let's look at the next question. How high is the pebble after 2.5 seconds? So again, thinking about the situation in this question, here's what's happening. And somewhere, presumably, 2.5 seconds later, what is the height? So is it close to the bridge still? I mean, we might even get a weird answer like, well, maybe it only took 1 second to fall, so it's actually, a negative weird answer. However, what we know is that we're looking for height. Height equals, I don't know, and time must be 2.5. So we're going to let t equal 2.5, and we're going to figure out what the height is. And again, if we get a weird answer for height, like a negative answer, it means that the pebble has actually already hit the water. So let's see what happens. Height equals 82 minus 4.9 times time squared. So in your calculator, let's do this math. So I get an answer of 51.4, oops, 51.4 meters. So after 2.5 seconds, the pebble is 51.4 meters above the water. I could also ask you, for example, how far has it fallen? In which case you would say, well, it started at 82, it's now at 51.4, and you would subtract them to figure that out. So we know that after 2.5 seconds, it's still above the water. So what else? How long does it take to hit the water? So visualizing, I want to know what time it is when it hits the water. So what does that mean about height? So we're finding time when the height is 0, because 0 represents the water, the height of the water. So we're going to let h equal 0, and we're going to solve for t. And in fact, let's use the rearranged formula that we had earlier. So everything's in its proper place. So now we're just going to solve for t. So how are we going to do it? Well, again, you could factor, you could complete the square and isolate. You could use the quadratic formula, but we don't get to do this very much. There's no b term. And since there's no b term, we can actually solve this like grade 9 style solving, which is we're just going to isolate the t. So I'm going to subtract 82 from both sides. I'm going to divide both sides by negative 4.9. So remember, we're isolating the t. So negative 82 divided by negative 4.9, that's going to give me 16.73. And then I'm going to take the square root of both sides. And remember, when you take the square root, you should get two answers. So I get 4.1, positive or negative. Now we know that negative 4.1 is inadmissible. That represents that imaginary mathematical side of the parabola, but not the actual real world application side. So we say inadmissible. And therefore, positive 4.1 seconds would be the answer to the question. That it takes 4.1 seconds to fall from 82 meters to a height of 0, which is the water's surface. Hope that helps. Thanks for watching.